Alright, hi. Piping inspection code, inspection repair, alteration, re-rating in-service piping systems, API 570, second edition, October 1998. Your pipe inspection code, inspection repair, alteration, re-rating in-service piping system downstream segment, API 570, second edition, October 1998. Alright, scope 1-1 general application 111 coverage. API 570 covers inspection, repair, alteration, re-rating procedures for metallic piping systems that have been in service. Intent: API 570 was developed with the petroleum refining chemical process industry, but may be used where practical for any piping system. It is intended for use of organization to maintain and have access, authorized inspection agency, repair organization, technical qualified piping engineer, inspectors, examiners, also defined in Section 3. Limitations: API 570 should not be used to substitute original construction requirements governing the piping system before it is placed in service, nor should it be used in conflict with prevailing regulatory requirements. 1.2 specific applications. 1.2.1 included fluid services, except for as provided in 1.2.2. API 570 applied with the piping system process fluids, hydrocarbons, and similar flammable toxic fluid services such as the following: raw intermediate finished petroleum products, raw intermediate finished chemical products, catalyst lines, hydrogen, natural gas, fuel gas, flare systems, sour water, hazard water, waste streams above threshold limited defined in jurisdictional regulations, hazard chemicals above threshold limits as defined in jurisdictional regulations. 1.2.2 excluded operation optional piping system. Fluid surface class for the piping system listed below are excluded for the specific requirements of API 570, but may include with the owners and users option. Fluid services are that exclude optional include hazard fluid services below threshold limited as defined in jurisdictional regulations. Water include fire protection system, steam condensate, boiler, feed water. Category D fluid services defined in American Society of Mechanical Engineers B31.3. Class of piping that are excluded or optional are as follows: piping system movable structure covered by the jurisdictional regulations, including piping system on a truck, ship, barges, other mobile equipment. Piping system that are an integral part of competent rotating reciprocating mechanical devices such as pump, compressors, turbines, generators, engines, hydraulics, pneumatic cylinders, where primary design consideration or stress are divided with the functional requirements of the device. Internal piping or tubing, fire heated and boilers include tube headers, return bends, external crossover the manifolds, pressure vessels, heaters, furnaces, heat exchangers, other fluid handling of the process. Equipment include internal piping connections for the external piping, plumbing, sanitary sewers, process wastewater storm sewers, piping and tubing with the outside diameter not exceeding the national NPS 1/2, non-metallic piping, and polymetric or glass line pipe. 2. References. The most recent editions of the following standard codes specifications cited in this code: API 510 pressure vessel inspection, publication 920 prevention of brittle fracture of the pressure vessels, publication 2201 procedure welding hot tapping equipment containable flammables, recommended practice 574 inspection piping system components, RP 651 cathodic protection above ground storage tanks, RP 750 management of process hazards, standard 598 valve inspection testing, guide for inspection refinery equipment, chapter 2. The document will be placed in the API recommended practice 571 conditions causing deterioration failures currently under development. API 570 inspector certification exam, body of knowledge, American Society of Mechanical Engineers, B1634 valve flange threaded welded end, B31.3 process piping, B31G manual determination remaining straight corroded pipelines, boiler vessel code section 8 division 1 and 2 section 9. The SNAT and SNTTC1 CP198 189 standard qualification certification on instructor testing personnel, ASTM G57 method of field measurement soil resistivity using Wiener Flower electric mode, and NACE. Recommended practice 0169 control external corrosion underground submerged metallic piping system. Recommended practice 0170 protection of all synthetic stainless steel polyethylene acid stress corrosion cracking during shutdown and refinery equipment. Recommended practice 0274 high voltage electrical inspection piping coatings prior to installation. Recommended practice 0275 application of organic coating external surface of the steel pipe and underground service. National Fire Protection Association 704 indication of high fire hazard material. are three definitions for the purpose of the standard following the definition apply. Alteration, physical change, any of the component with a design implication affecting the pressure contained with the compatibility, flexibility, piping system beyond the scope of the design following are not considered for the alteration comparable and duplicatable replacement. In addition, with a reinforced branch connection equal to or less than the size of the existing reinforced branch connections, the addition of the branch connections not requiring reinforcement. Applicable code. The code and code section otherwise recognized generally accepted by the engineer standard with the practice for the piping system was built, which is deemed by the owner user of the piping engineer to be most appropriate for a situation, included but not limited in this last edition of the American Society of Mechanical Engineers B313. ASME B313 is shortened form of the ASM B313 process piping published by the American Society of Mechanical Engineers. ASME B313 with the written design construction piping system. However, most of the technical requirements of the design, welding, examination materials also can be applied with the inspection, retesting, re-rating, repairing, and alteration of operating pipeline. ASME B313 cannot be filed because of the new construction coverage, such as revised new material specifications, inspection requirements, certain heat treatments, pressure tests. The piping engineer inspector should be guided with the API 570 in lieu of strict conformity. American Society of Mechanical Engineer B313, an example of the intent phrase of the principle ASME B313 has been employed with the American Petroleum Institute 570 rather than in accordance with the American Society of Mechanical Engineers B313. Authorized inspection agencies defined as the following: inspection organization with the jurisdiction of the piping system, either the inspection organization insurance company licensed registered with the right the insurance for the piping system, an owner user piping system that maintains inspection organization activity relating only to the equipment not for piping system intended for the sale of the reuse for sale or resale, independent inspection organization employed with under the contract owner and user piping system that has been used only by the user, owner and user for not for sale or resale, independent inspection organization license recognized by jurisdiction in which piping system is employed by under contractor for the owner and user. Authorized piping inspector employed with the authorized inspecting agent qualified, certified to perform functions specified with the API 570, non-instructive the examiner is not required to be an authorized piping inspector whenever the term inspector of the issue of the API 570 refers to authorized piping inspector. Auxiliary piping, the instrument with the machinery pipe with the typically small bore secondary process piping that can be isolated with the primary piping system. Examples include flush lines, seal oil lines, analyzer lines, balance lines, buffer gas lines, drains, and vents. Critical check valves have been identified with vital process safety and must operate reliably in order to avoid potential hazard events and substantial consequence should a leak occur. CUI corrosion under the insulation includes stress, corrosion, crack under insulation. Dead legs, components of piping system that normally no sufficient, non-significant flow. Examples include the following: blanked branches lines with the normally closed block valve lines with one end blanked, pressurized dummy support legs, stagnant control valve, bypass piping, spare pumping pump piping, level brittles, relief valve, inlet, outlet, header piping, pump trim, bypass lines, high point vents, same sample points, drain bleeders, instrument connections, defect, imperfection, type of the magnitude exceeding with the accessible criteria. Design temperature for the piping system component with the temperature in which of the coincident pressure of the greatest thickness of the highest component with the rating is required with the same design temperature defined with the American Society of Mechanical Engineer B313 with the other code section with the subject of the small rules relating to allowance the variation of the pressure temperature of both different components of the same piping of the system circuits may have different design temperatures. Establishing design temperatures consideration shall be given the process of fluid temperatures, ambient temperatures, heating and cooling, media temperatures, and insulation. Your examiner, a person who is the inspector with a performing specific non-destructive examination on piping system components that does not evaluate the result of the examination in accordance with the API 570, is specially trained and authorized to do so by owner or user. The examiner need not to be qualified in accordance with the API 570 by an employee of the owner or user should be trained and qualified in the applicable procedures in which the examiner is involved. In some cases, the examiner may be required to hold other certifications necessary to satisfy the owner and user requirements. Examples of other certifications have or may be SNTTC 1A or CP 189 or the AWS Welding Inspector Certification. The examiner employer shall maintain certification records, examiners employed, including dates. The result of the personal qualification shall make it available for the inspector. or your holding point, a point of repair and alteration process beyond which work may not proceed until the required inspection has been performed. Document imperfections, flaws, or other discontinuities not during the inspection that may be checked with accepted with criteria during the engineering inspection analysis. Indication response evidence resulting in the application of a non-destructive evaluation technique. Injection point. Location of relatively small quantities of the material are injected to the process stream with the control of the chemistry with the other process variables. Inspection points do not include location of the two process streams, joint mixing tees. Example, the injection points include chlorine and reformers, water injection and overhead system, polysulfide injection, catalytic cracking, wet gas, anti-foaming injectors, inhibitors, and neutralizers. In-service refers to piping systems that have been placed in operation opposed with new construction prior to it having placed in service. Inspector, authorized piping inspector, jurisdiction, a legally constituted government administrator that may adopt the rules relating to the pipe system, level level gauge glass piping assembly attached to the vessel, maximum allowable working pressure, or AMWP, the maximum internal pressure permitted in the piping system. Continued operation, most service conditions with coincidental internal and external pressure. Internal external pressure and the temperature minimum maximum expected during service is the same as the design procedure defined with the ASME B313. Other code sections and subject the same rules relating to allowance and the variation pressure, temperature, or both. A mixing tee is a piping component that combines two process streams of different composition over the temperature. MT, magnetic particle testing. NDE, non-destructive examination. NPS, nominal pipe size, followed when appropriate, the specific size, designated number without an inch and symbol. On-stream piping containing an amount of process fluid. Owner and user piping system will actually have the control over the operation, engineering, inspection, repair, alteration, testing, re-rating of the piping system. Owner and user inspector. Authorized inspector employed by the owner and user who qualified either with a written examination under the provisions Section 4, Appendix A, the API 57, that qualified under the provisions. A2, who meets the requirements of the jurisdictional. PTL liquid penetration test. Piping, a pressure-tight cylinder used to convey the fluid, a transmitted fluid pressure, and an ordinarily designated pipe applicable to the material specification. Material designated tubing, and specification are treated as pipe when intended for the pressure serve of the piping circuit. Section of pipe that has all piping points to the environmental similar corrosive that is on same design conditions. Construction material of the complex process of the piping circuit divided into the piping circuit circuits to manage necessary inspection calculation record, keeping an established boundary particular piping circuits. Inspector may also size the provide particular package for record keeping performing field inspection. Piping engineer. One or more persons organized except for the owner or usually knowledgeable, experience with the engineering disciplines associated with evaluating mechanical material characteristics, effectiveness, integrity, reliability of piping components of the system. Piping engineer may be consulted with the appropriate specialist, should be regarded with the composite of the all entities necessary to properly with the technical requirement. Your piping system assembly with the interconnected piping with the subject with the same set of the design conditions is used with the convey the distributed mixing, separated discharge, meter control, snub fluid flows. Piping system also should include pipe support elements that does not include with the support structures such as structural frames and foundation. Primary process piping. Process piping, the normal active surface that cannot be valved off, or if it were valved off, would significantly affect the unit operability. Primary purpose of the piping normally includes all process piping greater than nominal pipe size. 2. PWHC, post-weld heat treatment, renewal, activity discards existing components, replacing with new and existing spare materials, same or better quality as original component. Repair the work necessary to restore the pipeline system to the conditional, suitable, safe operation design conditions. If any restorative change result with the change of the design temperature or pressure, the requirements of the re-rating also should be satisfied. Any welding, cutting, grinding, operating on a pressure-containing pipe component not specifically considered an alteration is considered a repair. Repair organization in the following: owner and user piping system who repairs, alters his own or her own equipment in accordance with the API 570. Contracts with qualifications acceptable to the piper owner, user piping system who makes repairs, alteration in accordance with the API 570. Alright, one who's authorized by acceptable to otherwise prohibit the jurisdiction who make the repair in accordance with the API 570. Re-rating and change either or both the design temperature, maximum level of working pressure for the piping system. Re-rating may consider the increase or the decrease combination of both the de-rating below original design conditions may either provide increased corrosion allowance Secondary process piping, small bore less than equal to the national nominal pipe size. 2. Process piping downstream, normally closed block valve. Small bore piping, or SBP, piping that is less than or equal to nominal pipe size. 2. Soil, the air, or S/A interface. The air with external corrosion may occur with a partial buried up zone with the corrosion, depending on the factor of the moisture, oxygen content, and soil operating temperature. Zone generally is considered to be from 12 inches below to 6 inches above the soil surface of the pipe, running parallel with the soil surface with the contact soils included. Spool, a section of piping encompassed by flange or other connecting fittings such as unions. Temper embrittlement, loss of ductility, notch toughness, and suspected low alloy steels such as 11-4 chromium and the 21-4 chromium. Due to prolonged exposure at high temperatures, the surfaces at 700 degrees Fahrenheit to 10,070 degrees Fahrenheit. Temperature repairs made in the piping system in order to restore a sufficient integrity with a continued safety of the operation until the permanent repairs can be scheduled accomplished with a time of the period acceptable to the inspector by piping engineer. Test point are defined with a circle having the diameter no greater than 2 inches with a line diameter not exceeding 10 inches, not greater than 3 inches. For large line thickness reading may be averaged for this area. Test point should be within the thickness measurement location. Thickness measurement locations designated area of the piping system for periodic inspection. Thickness where measurements are conducted. Your WFMT, wet fluorescent magnetic particle testing. All right, 4. Owner and user inspection organization. General and owner or user point of piping should be external control, piping system inspection program, inspection frequencies, maintenance responsibility function, authorized inspector agency in accordance with the provision of API 570. Owner user inspection organization also control activities relating to the re-rating, repairing, alteration piping system. API authorized piping inspector qualification certification. Pipe inspector shall have the education and experience according with Appendix A in the inspection code. Authorized piping inspector certified with the American Petroleum Institute in accordance with the provisions of Appendix A. Whenever the term inspector of the document is referred to the authorized piping inspector. 4.3 responsibility. 4.3.1 owner and user. Owner and user organization responsible for developing, document, implementing, executing, accessing piping inspection systems and inspection procedures that will meet the requirements of the inspection code. These systems procedure will contain quality assurance inspection manual. Written procedures shall include organization, reporting structure, internal inspection personnel, documentation, maintaining inspection quality, and assurance procedures, documented reporting, inspection test result, corrective inspection test result, internal auditing, complying with the quality assurance inspection manual, review and approval of the drawings, design, location, specific repairs, and alteration, re-rating, ensuring all jurisdiction requirements, piping inspection, repair, alteration, re-rating of the continuously met, reporting of the authorized pipe inspector process chain with the code effect of the pipe integrity, training requirements for the inspection personnel regarding inspection tools, specific techniques, technical knowledge base, control necessary that only qualified welders procedures used in repairs, alteration, controls necessary so only qualified non-destructive examination personnel and procedures are utilized. Controls necessary only the material conform with the applicable specific sections of ASME code are utilized for the repairs alteration. Controls necessary so that the inspection measurement test equipment are properly maintained and calibrated. Controls necessary for the work of the contract inspection repair organization meet the same inspection requirements of the owner and organization. Internal auditing requirements of quality control system, pressure relief device, piping engineer. Piping engineer is responsible for the owner and user activities involved with the design, engineering, reviews, analysis, evaluation of pipe system covered in API 570. Repair organization shall be responsible for the owner and user provide with the materials, equipment quality, with the control, workmanship necessary for the maintaining of the repairing of the pipe system in accordance with the requirements of the API 570. The authorized piping inspector 434. When inspection, repair, alteration conducted with the piping system, the API authorized piping inspector shall be reasonable owner or user of the determining the requirements of API 570 on inspection, examination, and testing are met. Should be directly involved with the inspection activities. API authorized pipe inspector may be to be assisted with the performance visual inspection other perform properly trained qualified individuals who may or may not be certified pipe inspectors. Personal performing non-destructive examination shall meet the qualification identified in 312 need not to be API authorized pipe inspector. However, all examination must be evaluated except of the API authorized pipe inspector. 435. Other personnel, operating, maintenance, and other personnel who have special knowledge exercise related with a particular piping system shall be responsible for the prominently making the inspector piping engineer aware of the usual conditions that may develop provided with the other assistance appropriate. Alright, your inspection and testing practices. Risk-based inspection. Identify the evaluating potential degradation mechanisms are important steps in assessment of the likelihood of the piping failure. Here, adjustments, inspection strategies, tactics to account for the consequence of failure should also be considered for combining the assessment and likelihood of failure with the consequent failure, essential for the elements of risk-based inspection. When the owner chief of the conduct of the risk-based assessment is included with the systematic evaluation of both the likelihood of the failure, associated with the consequence of the failure, likelihood assessment with the based on all forms of degradation with a reasonable to be expected for the effect of the pipeline circuits, in particular, show with examples of the degradation mechanics include with the internal, and external metal off the identified form of erosion, localized or general, all forming the cracking, including hydrogen-assisted and stress corrosion, cracking the inside-outside surfacing of the pipe. Any other forms of metallurgic corrosion, mechanical degradation such as fatigue, embrittlement, creep, etc. Additional effectiveness in the inspection practices, tools, and techniques utilized with the finding expected of the potential degradation mechanism must be evaluated. Likelihood of the future failure assessment should be repeated each time the equipment and process changes are made that could significantly affect the degradation range caused by the perimeter failure of the piping. Other factors should be considered the risk-based inspection assessment include the appropriateness of the material for the construction piping circuit design conditions relative to the operation conditions appropriate to the design code and standard, the utilized effectiveness corrosion monitoring programs, quality maintenance inspection, quality assurance, quality control programs, equipment of failure information must be important for information for the assessment. The consequent assessment may consider the potential incident may occur with the result of the fluid release of the including explosion, fire, toxic exposure, and environmental impact, other health effects associated with the failure of the piping. Essential for the risk-based inspection assessment be thoroughly documented, clear, defining all the factors contributed in both likelihood of the consequence of the piping failure. Our preparation, cover the product, care with the piping, the safety precautions are important for the system, inspect with particularly with the opening with examining the internal surface with the procedure for the segregating pipe system, installing blank or blinds, testing tightening if there should be an integral part of the safety. Appropriate safety precautions should be taken before or after piping system open before some of the type of external inspection are performed. In general, the section pipe to be open with should be isolated from sources of harmful liquid, gas, vapor to purge to remove oil and toxic flame with the gas vapor before and starting inspection. Inspection personnel should be detained with the permission to do work for the sending operating personnel responsible for the piping system. The protective equipment shall be worn with the work when worn when required regulations. Only use of the non-destructive testing equipment used for inspection subject to the operating facility safety requirements. Electrical equipment. The general inspection inspectors should familiarize themselves with the prior inspection result of the repairing of the piping system, for which the responsible technician should brief the review of the history of individual piping system for making an inspector required to API 570. See Section 8 API for recommended practice 570 for supplemental recommended practices. 5.3 Inspection for the specific type of the corrosion, cracking, for more than thorough and complete information, see API RE Chapter 11. Each owner or user should provide specific attention for the need of the inspection piping system susceptible to the following specific type of the area: the deterioration, injection points, dead legs, corrosion under insulation, soil, the air interface, surface specified localized corrosion, and erosion, environmental cracking, corrosion beneath lining and deposit, fatigue, cracking, creep, cracking, brittle failure, brittle fracture, freezing, damage, other areas of concern with the noted with the IRE Chapter 2, Section 6, API recommended practice 574. 531 Injection points. Injection points are sometimes surface with accelerated localized corrosion with the normal or abnormal operation conditions. Those that may be treated with a separate inspection circuit, these are needed to be inspected early with a regular schedule. 5.1 Typical injection point piping circuit with a design with the inspection circuit for the purpose of the inspection recommended. The upstream limit of the injection point circuit is minimum of 12 inches for 3 pipe diameters upstream of the injection point, which is greater. Recommended downstream limit of the injection point circuit with the second change is flow direction past the injection point 25 feet beyond the first change of flow direction, whichever is less. In some cases, they may be appropriate to extend the circuit with the next piece of pressure equipment as shown in Figure 5.1. Selection of thickness and material or TML thickness measurement locations. But when injection point circuits are subject to localized corrosion, should be according to the following guidelines. Establish thickness measurement location appropriate fitting for the injection point circuit. Establish thickness measurement location of the pipe wall location exterior expected of the pipe will impingement of the injected fluid. Thickness measurement locations immediate with the location along with long straight pipe and injection point circuit that may be required. Establish thickness measurement locations at both upstream and downstream limited for the injection point circuit. The preferred method of inspection rejection point and inspection injection points are radiographically ultrasonic that is appropriate for the establishment of the minimum thickness of the thickness material location. Close grade ultrasonic measurement scanning may be used as long as the temperatures are appropriate. For some applications, beneficial to remove the piping spool to facilitate the visual inspection inside of the surface. However, the thickness measurement will still be required to determine the remaining thickness. During the periodic scheduled inspection, more extensive the inspection should be applied with an area being 12 inches for the upstream of the injection nozzle containing the last 10 piping diameters downstream of the injection point. Additional measured record thickness for the total measuring thickness measuring location injection point circuit. 532 dead legs. The corrosion rate of the dead legs can vary significantly with the adjacent active pipe, and the inspector should monitor the wall thickness with the selective dead legs, including both straight as staggered in connection with the active line and hot piping system. The high point area may corrode due to the corrosive content. Corrosive setup of the dead leg consideration should be given to remove the damaged dead legs to serve no further process purpose. Alright, corrosion under insulation. External inspection of the insulated piping system should include the review of the integrity of the insulation system for the conditions that could lead to corrosion under insulation for the sign of the ongoing corrosion under limit insulation. Sources of moisture may include rainwater leaks, condensation, dual lid system. Most common factor to become corrosion under insulation or localized corrosion, carbon, steel chloride, stress corrosion, cracking, austenitic steels, stainless steels. Section provides guidelines identifying with the potential for the corrosion under insulation areas of the inspection. Extent of the corrosion under insulation inspection program vary depending on the local climate. Warming marine locations may require a very active program where cooler, drier, mid-content locations may need not extensive propagate. Insulated piping system subject to corrosion under insulation. Certain areas, the type of the piping system, are potential for more susceptible to corrosion under insulation. Include the following: areas exposed to the mist overspray with the cooling water towers, areas exposed to the steam vents, areas exposed to the deluge system, areas exposed, areas subject to the process spills, ingress moisture, acid, vapor. Carbon steel piping system include those insulated with the personal protection operating between 25 degrees to 250 degrees Fahrenheit. Corrosion under insulation, particularly aggressive when the operating temperatures cause frequent continuous condensation, re-evaporation of the atmospheric moisture. Carbon steel piping system normally operate above 250 degrees Fahrenheit with intermittent surface of the dead legs and attachments protrude with the insulated pipeline operating different temperature. The operating temperature active line synthetic stainless steel piping system operating between 150 to 450 degrees Fahrenheit. These systems are susceptible chloride, stress, corrosion, cracking, vibrating piping. Systems have the tendency to inflict damage. Insulating jacket provided with a path of the water ingress steam trace piping system that may experience the tracing leaks, and especially with the tubing fittings beneath the insulation piping system with deteriorated coatings or rapid and common location piping system spec for the corrosion under insulation.